Normandy, July 1944. The Sherman tank, christened Cobra King, shuddered as its 75mm main gun fired, the concussion rippling through the hull. Sergeant Frank Miller, the gunner, watched through his periscopic sight as the distant hedgerow erupted in dust and splintered wood. Another German machine gun nest silenced. The stakes were clear. Maintain the momentum, keep the infantry moving, and punch through the stubborn Norman defenses that had bled the advance for weeks. This was the confidence of American armor, forged in North Africa and Sicily, now facing the grim reality of the bocage. Miller, a veteran of Kasserine Pass, had seen his share of German armor. He knew the panzers, their silhouettes etched into his memory from countless engagements. The Panzer IV, in particular, was often dismissed by American crews as a relic, a holdover from earlier campaigns, its angular form a familiar, almost comforting sight compared to the heavier, more menacing Tigers and Panthers. The common wisdom, reinforced by intelligence briefings and casual banter between engagements, was that the Panzer IV was slow, its armor inadequate, its main gun easily outmatched. Production logs from the Reich Ministry for Armaments and War Production indicated that over 8,500 Panzer IVs had been built by mid-1944, making it the most numerous German tank of the war. While many of these were earlier variants, the Ausf H and J, with their longer 7.5 cm Quak 40 L48 guns and increased armor, still formed a significant portion of the panzer divisions. These later models incorporated additional 30mm thick side skirts, known as Scherzen, designed to defeat anti-tank rifle rounds and early heat projectiles. Though American crews often regarded them as cosmetic, the M4 Sherman, by contrast, was the backbone of the Allied armored thrust. Its 75mm M3 gun, while effective against most German vehicles at close range, struggled against the frontal armor of later Panzer IVs beyond 500 meters. The Sherman's operational range was approximately 120 miles, with a top speed of 25 miles per hour on roads, making it a versatile, if not overwhelmingly powerful platform. American production lines had delivered over 49,000 Shermans by the war's end, a testament to industrial might and a belief in quantity over individual tank superiority. This numerical advantage, however, often fostered a tactical complacency. American tank doctrine emphasized maneuver and combined arms, but the expectation that any Panzer IV would be easily dispatched by a Sherman's 75mm round persisted. The early encounters in North Africa, where the short-barreled Panzer IV Ausf F1s were indeed outmatched by the M4, cemented this perception. The subsequent upgrades to the Panzer IV, particularly the introduction of the long-barreled Quak 40 L48 gun and thicker glasses plating, were frequently underestimated in the field. The prevailing sentiment among American tankers was that the Panzer IV represented a declining threat, a tank whose time had passed. This perception, while not entirely unfounded given the advent of the Panther and Tiger, overlooked the continuous evolution of the Panzer IV itself. Its continued presence on the battlefield, often in significant numbers, meant that underestimating its capabilities could have immediate and devastating consequences. Normandy, June 1944. The hedgerows, ancient and dense, offered a deceptive promise of cover. For the American infantry and their attached tank destroyers, the initial encounters with German armor were often exercises in frustration, punctuated by sudden, violent breakthroughs. The prevailing intelligence, filtered down from higher commands, had painted a picture of an enemy in decline, equipped largely with obsolescent designs, and the Panzer IV, in particular, was often dismissed as a relic, its silhouette familiar from North Africa and Sicily. The M10 tank destroyer, with its open-topped turret and 76mm main gun, was designed to ambush and destroy. Its armor, thin by design, prioritized speed and firepower, a doctrine that assumed engagement from a distance, or from hull-down positions. The M10's glacis plate, angled at 55 degrees, presented an effective thickness of 38 millimeters, while its turret front offered a mere 57 millimeter. These specifications were considered adequate against the anticipated threats, particularly the short-barreled Panzer IV variants. Early combat reports, however, began to tell a different story. Unit diaries from the 1st Infantry Division's attached tank destroyer battalions recorded instances of 75 millimeter rounds fired from Panzer IVs, penetrating the frontal armor of M10s at ranges exceeding 800 yards. This was a startling development. The Panzer IV, specifically the Ausf H and J models, had been upgunned with the KWK-40 L-48 7.5 centimeter cannon, a weapon capable of firing the PZGR-39 armor-piercing round. This projectile, weighing 6.8 kilograms, left the muzzle at 790 meters per second, possessing sufficient kinetic energy to defeat 80 millimeters of vertical rolled homogeneous armor at 100 meters, and still capable of penetrating 60 millimeter at 1,000 meters. The American M10 crews had been trained to identify the distinctive, boxy profile of the Panzer IV as a relatively easy kill. Their 76 millimeter M7 gun, firing the M62 APCBCT round, could penetrate 88 millimeters of vertical armor at 500 yards. On paper, this suggested a clear advantage. Yet the reality of combat in the bocage, with its obscured lines of sight and close-quarter engagements, often negated theoretical ballistic superiority. The Panzer IV, particularly the Ausf H, was equipped with 80 millimeter of frontal hull armor, an upgrade from earlier variants, and frequently featured additional 5 millimeter thick Schertzen side skirts designed to pre-detonate shaped charges and offer some protection against anti-tank rifle fire, though less effective against kinetic energy penetrators. The Germans, through continuous refinement, had transformed the Panzer IV from a medium tank into a formidable opponent, capable of holding its own against most Allied armor. Production figures from the Heereswaffenamt showed that by June 1944, over 8,000 Panzer IVs of all variants had been produced, with the Ausf H and J models constituting the bulk of the operational force in Normandy. This was not a declining force, but a numerically significant, continuously improved weapons system. The initial American overconfidence, born of outdated intelligence and a focus on the more heavily armored Panther and Tiger, began to dissipate with each unexpected penetration and each lost M10. The jokes about slow Panzer IVs faded quickly, replaced by a grim recognition of an underestimated adversary. The American gunners, settled into their positions, often remarked on the Panzer IVs they encountered. Their initial observations, frequently traded during lulls in engagement, centered on a perceived lack of speed, a visual sluggishness compared to the more agile armored cars or even the fleeting glimpses of Panther tanks. This assessment was not born of detailed technical analysis, but rather from the immediate, visceral experience of combat, where a tank's movement across the battlefield dictated the urgency of response. Their humor, a common coping mechanism, frequently targeted the Panzer IV's design. The squared-off turret and hull, lacking the sloped armor that characterized newer German designs, or even their own Shermans, struck them as an anachronism. They saw a silhouette that seemed to belong to an earlier phase of the war, a blunt instrument in an era of increasing sophistication. This visual impression, reinforced by the relative infrequency of truly devastating hits from the early models, fostered a dangerous complacency. Unit diaries from the 3rd Armored Division, specifically those detailing engagements in Normandy during the summer of 1944, record numerous instances of this casual dismissal. One entry notes, "Another slow Panzer IV lumbered into view. Easy pickings." This sentiment, while understandable in the context of their training and initial encounters, overlooked the continuous evolution of the Panzer IV. The early variants, indeed slower and less heavily armed, had given way to the Ausf, G, H, and J models, each iteration packing a more potent punch and improved protection. The perceived slowness was often a misinterpretation of tactical deployment. Panzer IVs, particularly the later models, were frequently used in supporting roles, providing a stable firing platform for their long-barreled 7.5-centimeter KWK-40 L48 main gun. This weapon, capable of penetrating 90 millimeters of armor at 100 meters with standard APCBC rounds, far exceeded the capabilities of earlier versions and posed a significant threat to the M4 Sherman, which possessed only 63 millimeters of frontal hull armor. The tank's deliberate movement was often a function of its mission, not an inherent deficiency. The psychological effect of this underestimation was profound. It led to a less cautious approach, a tendency to view the Panzer IV as a nuisance rather than a primary threat. This casual disdain, rooted in superficial observation and a lack of detailed intelligence on the latest German armor upgrades, created a vulnerability that would soon be brutally exposed. The gunners' jokes, a shield against the terror of battle, inadvertently lowered their guard against an adversary that had quietly become far more dangerous than they imagined. Normandy, July 1944. The M4 Sherman, with its 75mm main gun, had become the ubiquitous symbol of American armored might. Its silhouette a familiar sight across the hedgerow-laced bocage. American gunners, hardened by weeks of attrition and the slow, grinding advance, had developed a certain disdain for the German Panzer IV, a vehicle they often dismissed as an older, less formidable adversary compared to the heavier Panthers and Tigers. Intelligence briefings based on early encounters and captured materiel had reinforced this perception, emphasizing the Sherman's superior mobility and the 75mm gun's adequate performance against the Panzer IV's frontal armor at typical engagement ranges. The 75mm M3 gun, standard on most Shermans in the theater, fired an M61 armor-piercing capped shell with a muzzle velocity of approximately 619 meters per second. This round was capable of penetrating 76 millimeters of face-hardened armor sloped at 30 degrees from vertical at 500 yards. The Panzer IV Ausf-H, the most common variant encountered in mid-1944, presented a frontal glacis plate of 80 millimeters, often augmented by 5mm thick Schertzen side skirts and spaced armor on the turret, designed to pre-detonate hollow charge rounds. While the 80mm frontal plate theoretically offered a marginal advantage, American doctrine and experience suggested that flank shots or precise hits to weaker points would suffice, given the Panzer IV's perceived slower traverse and less powerful main armament compared to the newer German designs. This prevailing assessment was abruptly challenged on a sweltering afternoon near St. Lo. A company of the 2nd Armored Division, advancing through a narrow lane bordered by dense hedgerows, encountered unexpected resistance. A Panzer IV Ausf-H, concealed behind a thick embankment, opened fire without warning. The lead Sherman, an M4A1, was struck directly on its frontal glacis plate. The impact was immediate and catastrophic. The 7.5-centimeter KWK-40L 48 gun, firing a PZGR-39 armor-piercing composite rigid round, possessed a muzzle velocity of 790 meters per second. This projectile, weighing 6.8 kilograms, was designed to penetrate 96 millimeters of vertically sloped armor at 500 meters. The round, traveling at considerable velocity, cleanly perforated the Sherman's 51mm thick, cast homogeneous armor, which was sloped at 47 degrees from vertical, effectively presenting a line-of-sight thickness of approximately 75 millimeters. The projectile's kinetic energy, concentrated on a relatively small area, overcame the armor's resistance, punching through the steel and entering the fighting compartment. The internal spalling, combined with the primary projectile, ignited the stored ammunition and fuel. The Sherman erupted in a geyser of flame and smoke, its crew instantly incapacitated. Damage report indicated a complete loss of the vehicle and all personnel. The incident sent a chilling message through the American ranks. The assumption of the Panzer IV as an easily dispatched relic was shattered. The German tank, often underestimated, had proven its capacity to deliver a fatal blow to the Sherman, even through its frontal protection. This single engagement highlighted the critical vulnerability of the M4 Sherman to the Panzer IV's main gun at combat ranges, particularly when the German crews exploited terrain for ambush tactics. The tactical implication was immediate. American tank crews could no longer afford to treat the Panzer IV as a secondary threat, but as a capable adversary demanding the same respect and caution afforded to the heavier German tanks. The psychological impact rippled through the division, forcing a reevaluation of engagement strategies and a renewed appreciation for the destructive power of a seemingly outmatched foe. The acrid smell of propellant and scorched earth still hung heavy over the cratered landscape as the American ordnance teams began their grim work. They meticulously documented the damage, their flashlights cutting through the dust motes dancing in the morning light, revealing the steep geometry of destruction. The M4 Sherman, once a symbol of advancing Allied power, now lay twisted, its turret blown clear. A testament to the sudden, brutal efficacy of the engagement. The initial reports from the surviving crew members had been met with a degree of skepticism, a natural human tendency to rationalize extreme events. "It just went through," one gunner had stammered, his voice still raw with shock, describing a penetration that defied their ingrained assumptions about the Panzer IV. The official damage assessment, however, began to corroborate these accounts with chilling precision. The armored plate of the Sherman's hull, a 63mm thick section of rolled homogeneous armor, showed a clean, almost surgical entry point. The projectile had not merely spalled or ricocheted. It had punched straight through, leaving a distinct circular hole with minimal deformation around the edges. This was not the ragged tear of a high-explosive shell, nor the glancing blow of an underpowered anti-tank round. This was a kinetic energy penetrator, delivering its destructive force with focused intent. Examination of the recovered fragments, painstakingly sifted from the churned earth and mangled interior, confirmed the weapon's identity. The distinctive fluted base and tungsten carbide core pointed unmistakably to the German 7.5 cm KWK-40 L48, the main gun mounted on the later variants of the Panzer IV. This was a gun they had previously considered a nuisance, an older design, certainly not a peer to their own 75mm M3 or the newer 76mm M1. Production logs from German armaments factories indicated that by 1943, the KWK-40 L48 was being manufactured at a rate exceeding 1,200 units per month, steadily replacing the shorter L43 gun. This standardization meant that the encounter was not an anomaly, but a harbinger of a more potent threat. The projectile, the 7.5 cm PZGR-39, typically achieved a muzzle velocity of 790 meters per second, capable of penetrating 96mm of vertical armor at 500 meters. The Sherman's 63mm frontal plate, angled at 47 degrees, presented an effective thickness, but clearly not enough to withstand a direct hit at close range. The strategic implication was immediate and profound. American tank doctrine, which had often emphasized speed and maneuverability over heavy armor, suddenly faced a stark reevaluation. The perceived invulnerability of the M4 Sherman, particularly against the more common German tanks, was now shattered. This single penetration, documented and analyzed, would ripple through training manuals and procurement requests, demanding a shift in tactics and a renewed focus on upgunning and improved armor. Washington, D.C., late 1944. The after-action reports from the Ardennes began to coalesce into a grim picture. challenging preconceived notions of German armored capabilities. Initial intelligence assessments, often colored by earlier North African and Sicilian engagements, had consistently underestimated the pace of German design and manufacturing adaptation. The prevailing sentiment among some strategic planners had been that the Wehrmacht's most potent designs were either too complex for mass production or too unreliable for sustained combat. This illusion was now shattered by a cascade of field data. Detailed metallurgical analyses of captured German armor, particularly from the Panther and later Tiger II tanks, revealed a consistent, if sometimes inconsistent in quality, application of face-hardened steel and sophisticated welding techniques. These findings contrasted sharply with earlier assumptions that German industry, under relentless Allied bombing, would be forced to compromise on fundamental material science. Instead, the Germans had prioritized protection and firepower, even at the cost of production volume and mechanical reliability, a trade-off that directly impacted American battlefield doctrine. The thickness of the frontal glacis on the Panther D, for instance, measured consistently at 80 millimeters, sloped at 55 degrees from the vertical, presenting an effective line of sight thickness significantly greater than any American tank gun could reliably defeat at combat ranges. Production logs, painstakingly reconstructed from captured factory records and interrogation files, indicated that despite the Allied air superiority and strategic bombing campaigns, German tank output had not only been sustained, but in some critical categories had actually increased. The Panther tank, initially a rarity, saw its monthly production climb from 148 units in July 1943 to a peak of 400 units in July 1944. This quantitative surge, often overlooked in the broader narrative of German industrial collapse, meant that American forces were increasingly encountering these formidable machines, not as isolated threats, but as integral components of German armored divisions. The implication was clear. The enemy, far from being a spent force, was still capable of fielding technologically advanced and numerically significant armored formations. The strategic implications rippled through the planning offices. The notion that the Panzer IV represented the zenith of German medium tank design, a belief that had fostered a degree of complacency, was now thoroughly discredited. The Panther and Tiger tanks were not simply incremental improvements. They represented a qualitative leap in armored warfare, demanding a fundamental reevaluation of American tank design, anti-tank weaponry, and tactical doctrine. The M4 Sherman, while reliable and produced in vast numbers, was increasingly outmatched, its 75mm and even 76mm guns struggling to penetrate the frontal armor of these newer German designs. This disparity forced American tank crews to adopt flanking maneuvers, often at great risk, or to rely on overwhelming numerical superiority and air support to overcome individual German tanks. Ideologically, this realization was equally profound. The narrative of German technological decline, a comforting story for Allied morale, had to be abandoned. The Wehrmacht was not simply fighting with obsolescent equipment, it was innovating, adapting, and producing weapon systems that were, in many respects, superior to their Allied counterparts. This understanding necessitated a shift from an assumption of inevitable technological advantage to a recognition of a persistent and dangerous arms race, even in the war's final stages. The very notion of a slow Panzer IV became a symbol of a dangerous underestimation, a costly lesson learned in the frozen forests of the Ardennes. The quiet reflection in the war rooms centered on the cost of this overs. The casualty reports, the lost materiel, the stalled offensives, all pointed to a gap in intelligence and strategic foresight. The enemy had not adhered to the convenient narrative of decline. They had instead poured their dwindling resources into a desperate and often effective technological gambit. The consequence was a renewed urgency in the development of heavier American tanks and more powerful anti-tank guns, a race against time to counter a threat that had been for too long dismissed. The lessons learned from the penetration of concrete and steel were not confined to after-action reports. Field modifications began almost immediately, driven by the stark necessity of survival. Crews, recognizing the limitations of their existing emplacements, began to improvise, stacking sandbags, timber, and even salvaged track links against vulnerable points, hoping to dissipate kinetic energy before it reached the primary structure. This was a stopgap, a desperate measure born of immediate threat, but it underscored the urgent need for a more robust solution. Official channels responded with a series of directives aimed at improving defensive structures. Engineers reevaluated standard concrete specifications, increasing aggregate density and reinforcing bar schedules for forward positions. The thickness of frontal armor on static emplacements, previously deemed adequate for all but the heaviest naval ordnance, was incrementally increased. Production logs from construction battalions in late 1944 show a 15% increase in steel rebar usage per cubic yard of concrete for new pillbox designs compared to early 1944 specifications. The most significant adaptation, however, came in the form of specialized anti-tank obstacles. The Czech Hedgehog, a simple yet effective arrangement of steel graters designed to snag and flip tanks, saw widespread deployment. Dragon's Teeth, concrete tetrahedrons arrayed in dense fields, were poured in greater numbers, their purpose to slow and channel enemy armor into pre-sighted kill zones. These passive defenses, while not directly engaging the threat, bought precious seconds, forcing tanks to expose their flanks or become bogged down, making them vulnerable to direct fire. Artillery doctrine also underwent a subtle but critical shift. Rather than relying solely on area suppression, forward observers were explicitly instructed to prioritize individual armored targets, especially during breakthrough attempts. The 105mm howitzer, previously considered a general support weapon, was now often tasked with direct fire missions against identified hard targets, utilizing high-explosive anti-tank heat rounds when available. These rounds, with their shaped charges, offered a better chance of penetrating thicker armor than standard high-explosive shells, even at oblique angles. The M36 tank destroyer, a purpose-built vehicle designed to engage heavy German armor, began to arrive in greater numbers, its 90mm main gun a direct answer to the increasing threat posed by the Panther and later variants of the Panzer IV. Its thinner armor, a compromise for speed and maneuverability, meant it could not withstand a direct hit from a German 7.5cm KWK-40, but its superior firepower allowed it to engage at ranges where its own vulnerability was lessened. Production figures from the Detroit arsenal show an increase from 100 units per month in August 1944 to over 300 units per month by December, reflecting the urgency of this countermeasure. Training regimens were updated to emphasize target identification and the specific vulnerabilities of German tanks. Gunners were taught to aim for vision ports, drive sprockets, and engine decks, recognizing that a direct frontal engagement against a well-armored Panzer IV often proved futile. Mock-ups of German armor were constructed at training grounds, allowing crews to practice shot placement against specific weak points. The psychological impact of seeing a seemingly impenetrable tank brought to a halt by a well-aimed shot was deemed crucial for morale and effectiveness. The development of new ammunition types also accelerated. While the initial shock of the Panzer IV's penetration had been absorbed by existing anti-tank rounds, the push for more effective projectiles intensified. Tungsten-cored armor-piercing composite rigid APCR rounds, designed for higher velocity and improved penetration, saw increased production, though scarce and often reserved for specific units. Their deployment signaled a recognition that the arms race was continuous, and that static defenses alone would never be enough to contain a dynamic threat. The incident at the crossroads, while seemingly isolated, resonated through the American lines, reinforcing a difficult truth about the nature of combat. Assumptions, even those born from prior successes or perceived technological superiority, carried a lethal cost when confronted by a determined enemy. The Panzer IV, once dismissed, had demonstrated its capacity for unexpected violence, forcing a reassessment of its threat profile. This shift in perception was not unique to the American experience. Throughout the war, every major combatant faced similar revelations, often at great human expense. The initial engagements on the Eastern Front, for instance, saw German forces underestimating Soviet tank designs, particularly the T-34, leading to rapid and brutal reevaluations of their own armor and anti-tank capabilities. These moments of violent instruction served as catalysts for accelerated development and tactical adaptation. The constant pressure of an evolving battlefield demanded continuous innovation, not just in design, but in doctrine. Static thinking, the reliance on past performance as a predictor of future outcomes, proved a fatal flaw. The very systems of intelligence gathering and threat assessment were under constant scrutiny, attempting to filter out biases and accurately gauge enemy capabilities, even when those capabilities seemed to contradict established narratives. The production figures from the latter half of 1944 illustrate this relentless pursuit of advantage. American factories, having already achieved staggering output, continued to refine and increase the lethality of their anti-tank weaponry. The 76mm gun, initially viewed as an adequate upgrade, was itself being superseded by the development of the 90mm and even experimental 105mm tank guns, driven by the need to counter increasingly formidable German armor, including the heavier Panther and Tiger tanks. These developments were a direct consequence of lessons learned in the field, often from encounters like the one that shattered the